So welcome to Electronics 6LA, and you are watching Digital Electron Lecture Series. And today the topic of discussion is the RS flip-flop using the NOR gates. So in the previous section we have discussed how the RS flip-flop can be constructed using the NAND gate as a latch. Okay. So in this section we will see how the RS flip-flop can be constructed using the NOR gate as a latch. So we have seen that the flip-flops can be constructed using the three sections. One of the section is a edge detector circuit. The second section is the steering gates. The third section is the latches. Okay. So basically the flip flops are constructed using the latches. So here we are using the NOR gate as a latch. Okay. So let us see how the circuit operates with different combinations of inputs, that is R and S. Okay. So let us get into our discussion. So the circuit consists of basic NOR gate latch. So we are using here the NOR gate as a latch. Okay, and we have two AND gates at the input. So two AND gates are used as the steering gates, and basically the NOR gates are used as a latch. Okay, the internal circuitry of as I have told you that the internal circuitry of S triggered RS flip flop consists of the three sections. One of the section is your edge detector circuit. Second section is the steering gates. The third section is the means latches. Okay. So let us see how the circuit looks like. So this is the logic diagram of a RS flip flop. So you can see here there are G3 and G4 forms a latch. This form a latch. Okay. So we are using this uh, NOR based latch. Okay. So then now we have the steering gates. That is the G1 and G2 from the steering gates. So what is the use of steering gates? It is the steering gates actually used to control the flow of data into the latches depending upon the clock and the inputs. Okay. Similarly, we have a means pulse transition detector. The clock is passed through the pulse transition detector. Okay. Uh, so then we have the steering gates and we have the latches. So we have basically there are three sections are there in any flip flop. We can see there are three sections are there. So one of the section is your pulse transition detector, or it is also called the edge detector. So this will detect the edge. Okay. The flip flops are actually edge triggered device. That is why it detects the edge of this clock. Okay. Then we have a steering gates. The steering gates control the flow of data into the latches depending upon this clock and R means inputs. Okay. Similarly, we have a latch. This latch is used to store the information. Okay. So these are the three section of that RS flip flop. Okay. So this we have the steering gates that are the G1 and G2. This form of steering gates. So these are the AND gates are there. Okay. So the if the clock is zero, so you can see if the clock is zero, the output of closed circuit is zero, then the gate output will be G1 and G2. The output will be zero. Okay. So regardless of this R and S, okay, the output of this steering gates will be zero. Okay. So that is the AND gates output is zero as long as the clock is zero, regardless of this RSL inputs. Okay. So next, when the clock is 1, then the information from RSS inputs is allowed to reach the basic RS latch. Okay. So this circuit is going to work when the clock is equal to 1. Okay. So you can see that when clock is absent, the circuit remains in the same state. Okay. So there is no change of the state takes place when the clock is 0. Okay. Then when the clock is 1 or there is a clock, then the RS people work as the basic RS latch. Okay. That is we are going to see how this RS flip-flop is work as a basic RS latch. Okay. So similarly, we have this is the logic symbol of this RS flip-flop. Okay. So you can ask me why there is AND gates are there, why not any other gates? Okay. So if we have the NOR gates is there, okay. If there is a NOR gates are there, basically what will happen is that if there is this G1 and G2 are, if there is a NOR gate are there, so if we use this as a NOR gate, so what will happen is that if suppose there is clock is there, okay, so clock is there means, so what is the speciality of NOR gate is that if there is a 1 at the input of the NOR gate, it forces the output to be 0, okay. So if there is a clock is present, then also the output of G1 and G2 NOR based, that if we replace G1 and G2 by NOR gates, then only that also the output of G1 and G2 will be 0 if there is a NOR gate. G1 is a NOR gate and G2 is a NOR gate. Okay. So the circuit is will be written in the same state. Okay. So that is how why we are using this G1 and G2. That is why we are using as the means AND gates. Okay. So that is the reason why you are using the AND gates. Okay. So let us see the working of this RS flip flop using the NOR gate as a latch. Okay. So this is the means we have seen that NOR gate. If any input of the NOR gate is 1, it forces the output to the logic 0. Okay. So let us see the working of this latch means flip flop using the NOR based latch with different combinations of RNS. So first case is that the R value is 0 and S value equal to 1. Okay. So this is the circuit logic diagram of a R flip flop. So in this case, we are applying R value is 0 and S equal to 1. Okay. So R value is 0 and S value equal to 1. Okay. The clock is 1. Okay. The clock is 1. So what will be the output now? The output of the G1 will be, so it will be 0 because one of the input of the this AND gate is 0. So 0 and this 1 and 1 output of G2 will be 1. Okay. So then we're going to apply this property. If logic 1 had any of input of the NOR gate, it forces the output to be 0. Okay. So G4 has the one of the input as the 1. Okay. So it forces the output to be 0. So this Q bar will be 1. Okay. So Q bar equal to 1. So Q bar is connected to the one of the input of this G3. Okay. Then the output will be, what will be the output now? The G3. So G3 accept the inputs in 0 and 0. The output equal to 1. Okay. So basically this condition is called the state condition. Okay. So when R equal to 0 and S equal to 1, the latch output is in the state. That is the Q equal to 1 and Q bar equal to 0. Okay. So let us see our second case. So case 2, when R equal to 1 and S equal to 0. Okay. So now we are applying R equal to 1 and S equal to 0. Okay. So the clock is 1. Okay. This clock is 1. So the what will the output of G1? So G1 output equal to, it will be 1 and G2 output will be 0. Okay. So 1 and 0. So if any of the input of the NOR gate is 1, it forces the output to be 0. So G3 output will be, this G3 output will be means 0. Then Q is connected to the one of the input of this G4. Okay. So 0 and 0, what will the output? The Q bar equal to 1. Okay. So you can see this uh, when R equal to 1 and S equal to 0, the Q equal to 0 and Q bar equal to 1. This condition is called as the reset condition. Okay. So when R equal to 1 and S equal to 0, the latch output is in the reset state. Okay. So this is our second case. Okay. Let us see our third case. So third case is that both the inputs are 0 and 0. Okay. So let us assume that this Q equal to 0 and Q bar equal to 1. Okay. So here we are applying R equal to 0 and S equal to 0. Both the input of this flip-flop is 0 and 0. Okay. And the clock is equal to 1. Okay. So now what will the output? So this will be G1, the output equal to 0 and G2 output also 0. Okay. So then we cannot predict this output Q and Q bar. That is why you have to assume that we have seen in the case of the latches also. So we are first assuming that Q equal to 0 and Q bar equal to 1. Okay. Then this Q is connected to the one of the input of G4. Again, Q bar is connected to the one of the input of G3. Okay. Let's see that. So this 0 is comes over here. Okay. And this 1 is comes over here. Okay. The 0 and 1, what will the output? The output will be 0. Okay. Similarly, G4 has the inputs, both the inputs are 0 and 0. The output will be equal to 1. Okay. So this is our first assumption. So you can see whatever we have assumed, the same thing we are getting. Okay. So it matches the initial assumptions. Okay. Let us see our second assumption. Okay. The second assumption is that Q equal to 1 and Q bar equal to 0. In this case also, the RNS value are 0, 0. So RNS value are 0, 0. So we have here the clock equal to 1. Okay. The clock equal to 1. So what will the output? So G1 output equal to that will be 0, and G2 also 0. Output of G2 equal to 0. So we are assuming now Q equal to 1 and QR equal to 0. Now this 1 comes over here. Okay. Similarly, this 0, that is the Q4, is connected to the one of the input of G3. So this 0 is comes over here. So G3 has both the inputs and 0, 0. What will the output? The output equal to 1. Similarly, G4 has both the inputs are, means one of the input is 1, second input is 0. So the output equal to 0. Okay. So you can see in both the cases, that is the both our assumption, you can see that means A and B, both the assumptions that matches the initial assumptions. Okay. So that is why it remains in the previous state, or it is in the no change state. So when R equal to 0 and S equal to 0, the latch remains in latch in the previous state. Okay. So this is our third case. Okay. Similarly, our fourth case, or the last case, is that both the inputs of R and S are equal to 1, 1. Okay. So both the inputs of R and S equal to 1, 1, and the clock equal to, you can see the clock equal to 1. Okay. So what will the output? So G1 and G2, both the output equal to 1 and 1. Okay. So both the output equal to 1, 1, 1. Then if both the means G3 has the one of the input is 1. Okay. So if any input of the NOR gate is equal to 1, so it causes the output to be 0. So both the Q and QR, that will be 0. Okay. So that is the thing. It is the that means not means indeterminate state, because this Q and Q complement will be complementary to each other. That is why we can say this is in the prohibited state or invalid state. So when R equal to 1 and S equal to 1, the latch output in the prohibited state. So this is the disadvantage of this RS flip-flop. Okay. So let us summarize in the form of a truth table. So if there is no clock, then we have the no change state. Okay. If the clock is 1, the R and S value are 0, 0. In this case also, the latch output in the means last state. Okay. So in order to set this latch, we can apply R value is 0 and S value equal to 1. Similarly, if R value equal to 1 and S equal to 0, the latch would be in the reset state. Okay. So if R and S both are 1, 1, then it is in the indeterminate states. Okay. So you can see in this case, in these cases, we are applying the clock. Okay. The clock is there. Okay. So we have seen that how the RS flip-flop can be constructed using the NOR-based latch. Then we have seen the truth table of this RS flip-flop using the NOR-based latch. Okay. So these slides are prepared by using these two books. One of the book is from Anand Kumar. Okay. The second book is from P. Raja. Okay. So stay connected to this channel. Thank you for watching this video. If you have any doubt, you can comment me in the comment box. Thank you all. So have a nice day.